The 30th question. In the figure, ABCD is a parallelogram, a semicircle with center O, and the diameter AB has been drawn and it passes through D. If AB is equal to 12 centimeters and OD perpendicular to AB, then find the area of the shaded region. He is asking you to use pi as 3.14. Now, let us draw the diagram. So, the shaded portion is the triangle AOB and the region outside the semicircle. Given AB is equal to 12 centimeters, angle AOB is equal to half times B times H. Now we know AO is equal to OD is the radii, which is equal to 6 centimeters. So, area of the triangle AOD is equal to half into 6 into 6, which is equal to 18 centimeters square. Now, the portion ODBC, it is a quadrilateral with OD as the height, and one of the sides is OB and the other side is OC. Now we know the area of the quadrilateral is half H into A plus B, which is the area of the quadrilateral ODBC. Now substituting the values, we get half, H is 6, A is 6 plus 12, which is nothing but 54 centimeters square. Now, this region which is required to be found is nothing but the quadrant, the quadrilateral minus the quadrant. Now, area of the quadrant is equal to area of the quadrant ODB is equal to 1 by 4 into pi r square. 3.14 into r is 6 times 6, or which is equal to 28.26. Now, subtracting 54 minus 28.26 gives you 25.74. Now, the required area is the area of the triangle AOD plus this region of BDC. So, now adding up both 25.74 plus 18 gives you 43.74 centimeters square. Hence, the required area is 43.74. The 31st problem. A game in a booth at a Diwali fair involves using a pointer first. Then if the spinner stops on an even number, the player is allowed to pick a marble from the bag. The spinner and the marble in the bag are represented in this figure. Prizes are given when a black marble is packed. Shweta plays the game once. What is the probability that she will be allowed to pick a marble from the bag? The second subdivision says, suppose she is allowed to pick a marble from the bag, what is the probability of getting a prize when it is given that the bag contains 20 balls and of which 6 are black? Now let us see the first subdivision. What is the probability that she will be allowed to pick a marble from the bag? To enter into the game, the pointer, he says, it should now rest on the even number. So, the number of even numbers is 1, 2, 3, 4, 5 out of 6. So, the probability of getting an even number is 5 out of 6. So, for the first question, the probability is 5 by 6. And for the second subdivision, he says, suppose the bag she is allowed to pick a marble from the bag. What is the probability of getting a prize? So the bag contains 6 out of 20. So the probability of winning the game is now going to be 6 over 20, which is equal to 3 over 10. The 32nd question. A fraction becomes 1 by 3 when 1 is subtracted from the numerator, and it becomes 1 by 4 When 8 is added to the denominator, find the fraction. Let the fraction be x by y. The first condition, when 1 is subtracted from the numerator, that is x minus 1 by y, the fraction becomes 1 by 3. Now cross multiplying, you get 3x minus 3 is equal to y, or 3x minus y is equal to 3. Let that be the first equation. The second condition says that when 8 is added to the denominator, it becomes 1 by 4. So x by y plus 8 is equal to 1 by 4. Same way, cross multiply it, you get it as 4x is equal to y plus 8, or 4x minus y is equal to 8. Let that be the second equation. Now solving both the equation by substitution method. So 4x by elimination method, 4x minus y is equal to 8. The first equation is 3x minus y is equal to 3. Let us subtract both the equations, change the symbols, y and y gets cancelled. So minus x is equal to minus 5. This implies x is equal to 5. Now substituting the value of x in one of the equations, you get 3 in the first equation. 3 times 5 minus y is equal to 3, or 15 minus y is equal to 3, or minus y is equal to 3 minus 15, or y is equal to 12. Hence the fraction is 5 by 12. Our question for this: the present age of a father is 3 years more than 3 times the age of his son. 3 years hence, the father's age will be 10 years more than twice the age of the son. Determine their present ages. Okay. Let the father's age be x and the son's age be y. So, by the given condition, he says the present age of the father in 3 years is 3 years more than 3 times the age of the son, which means x is equal to 3y plus 3, or x minus 3y is equal to 3 is the first equation. Next, he says 3 years hence the father will be 10 years more than twice the age of the son. In that case, father's age will be x plus 3 is equal to 2 times y plus 3 plus 10. Now simplifying that, you get it as x minus 2y is equal to 30. Or let that be the second equation. Now solving both the equation, the first and the second equation, we get it as x minus 3y is equal to 3, x minus 2y is equal to 30. Subtract both the equations. So that would give you minus y is equal to minus 10, or y is equal to 10. If y is equal to 10, that is the son's age is 10. So x is equal to 3 times 10 plus 3, which is equal to 33. So the father's age is 33. Find the ratio in which the y-axis divides a line segment joining the points 6, minus 4 and minus 2, minus 7. Also find the points of intersection. So this is the 33rd sum. So you know, the point on the y-axis or the coordinate of any point on the y-axis is 0, y. He says the ratio in which the y-axis divides a line segment joining the points. So let us take A to be 6, minus 4 and B minus 2, minus 7. Now we don't know the ratio. Let the ratios be m and n. Now we know the coordinate for the x coordinate is mx2 plus nx1 by m plus n, and the y so let us now first find out the x coordinate. So Because the x coordinate is equal to 0, we can equate it to 0. So m into x2 is minus 2 plus n into x1 is 6 divided by m plus n is equal to 0, or this shows that minus 2m plus 6n is equal to 0, or this implies 2m is equal to 6n, or m by n is equal to 6 by 2, which is equal to 3 by 1. So the ratio is m is to n is 3 is to 1. Now to find out the coordinates or the point of intersection, let us now substitute the ratio 3 is to 1 for the y coordinate. Then gives you 3 times minus 7 plus 1 into minus 4 by 3 plus 1, which is equal to minus 21 minus 4 by 4, which is equal to 25 by 4. So the point of intersection is 0, minus 25 by 4. The OR sum, show that the points 7, 10, to minus 2, 5 and 3, minus 4 are the vertices of an isosceles right triangle. So let the vertices be A, B, C. A is 7, 10, B is minus 2, 5 and C is 7, 10. Now using distance formula, root over x2 minus x1 the whole square plus y2 minus y1 the whole square. Now substitute, let us find out AB. The coordinates are 7, 10 and minus 2, 5. So let us take that. x2 is root over minus 2 minus 7 the whole square plus 5 minus 10 the whole square, which is nothing but root of minus 9 the whole squared is 81 plus minus 5 the whole squared is 25. So 81 plus 25 is 6, root 106. Next, let us find out BC. BC, same way, root of 7 minus of minus 2 is plus 2 the whole square plus 10 minus of 5 the whole square, which is equal to root of 9 square 81 plus 5 square is 25, which is equal to root of 106. Now we can see that two sides are equal, so it is an isosceles triangle. It is an isosceles triangle because AB is equal to BC. Next we have to prove that it is a right triangle. Let us also find out AC now. AC, same way, root of AC is 7, 10 and C is also equal to, oh my god, 3, 4. Let me mark this as 3, 4.